Good morning, everyone. Have you ever had the need to extend and retract a motorized actuator? I've got the box for you. I've made this little circuit right here. It's real easy to put together. And it takes one button input to extend the motorized actuator, a second button input to retract the motorized actuator. There's also a switch input right here that disables and enables the retract function. This will run off of a 12-volt car battery, and here is the terminals for the connection to the DC motor inside the actuator. Let's hook it up and test it. At the end of the video, when I get to the house, I'll put the circuit up and we'll talk about how it actually works. Now here's what's inside. I have two relays. Here's K1 and here's K2. And the contacts, the solder points of the relays are soldered to two terminal boards to give you easy access to your wiring. I'm using this external power supply to apply 12 volts in ground. Here is our extend switch. Here's our retract switch. This switch right here enables and disables the retract function. I have two LEDs to simulate the actuator DC motor. And green is extend and red is retract. Let's test the circuit. Here's 12 volts and ground from the external power supply coming into the box. Now I'm going to push this button to extend the actuator. The green LED will come on, simulating a positive voltage, a positive DC voltage being applied to the actuator's DC motor. Push and hold that button. Now the actuator would be extending out. Release the button and it would stop. Let's go the other way. This push button right here will retract the actuator. The red LED comes on, simulating that a negative 12 volts DC has been applied to the actuator, bringing it back. Let go of the button and the motor would stop. Now there's a couple of safeties in here. The relays are configured in an H-bridge configuration, and if I was able to turn both relays on at the same time, I would effectively apply 12 volts directly to ground through those two relays. We don't want to do that. So let me show you the safety in action. Let's say we're extending out and I accidentally push at the same time the retract push button. Both LEDs are off. There's no DC voltage applied to that actuator. So one push button, we're going. Both push buttons, we've stopped. We're moving. With one push button, we're stopped when I push both push buttons. That prevents an accidental short circuit from 12 volts to ground if I were to push both buttons at the same time. This switch over here, this enables and disables the retract function. Now, when I send the actuator to the position I want it to stop at, I don't want it to come back. I want it to stay there, and if I accidentally push the retract push button, it would come back. So I extend it out to the position I want it to go, and I would disable the retract function by opening up that switch right there. Now you can still hear the relay click, but the 12 volts is not being applied to the motor in that actuator. You can see that by the LED not coming on. Now when I wanted to retract, I flipped the switch to close it, and now 12 volts is being applied to the actuator's DC motor. Oh, isn't that neat? I like that. Simple circuit. We'll see how it works on paper when we get to the house. We got a little bit of work to do here yet, so it'll be a little while before I get there. See you shortly. Evening all. Let's talk about the actuator extend retract unit that I put together. Now when we push PB1 closed, 12 volts DC is applied to the K1 relay to ground. When K1 is energized, the actuator moves out to its extended position. If we released PB1, if we opened up PB1, that actuator would stop at the position we release that position, that push button. Now to bring it back, to retract it, we push PB2, push button 2, and that energizes the K2 relay, which brings the actuator back to the retracted position. If we were to release push button 2 before we reached the fully retracted position, that motor would stop in the actuator. So we have two push buttons: extend to energize K1 and retract to energize K2. Now we're sitting sideways here, but it's the best way to get a bigger picture of what's going on with my drawing. Here, no buttons are pressed. The K1 and K2 relays are de-energized. Up here we have a normally closed contact for K1, a normally closed contact for K2, and we have K1 here open, K1 down here open, K2 up here open, and K2 down here open. The S1 switch is for disabling and enabling the retract function, and here it is closed. Let's explain why we have to have a normally closed contact of K2 and K1 before we discuss any other mode of this relay functions. If we were able to close K1 and K2 at the same time, we would have a short circuit from plus 12 volts DC through K1 and K2 back to ground on both sides. But the normally closed contacts here disengage K1 or K2 depending on which direction we're moving. So, for instance, if I energize K1 here, and these two contacts up here close, this K1 normally closed contact opens up, and current cannot flow through the K2 side and create that short circuit from plus 12 volts DC to ground through the K1 and K2 relays. And it works both ways. Let's say we're moving in the retract side and current flows through K2 to ground, but the K2 contact is opened up, so that if the K1 relay was energized, you would not have current flow through the K1 and K2 contacts. It would only flow through the K1 normally closed, K2 closed, K2 closed down here, back to ground. Now here's push button 1 pressed to extend the actuator out. Here's our plus 12 volts DC. It flows through the K2 normally closed contact. Up here K1 has opened. Through the K1 contact, through the actuator DC motor, through the K1 contact, back to ground. Look at the polarity. We have plus from the car battery applied to this side of the DC motor in the actuator. We have ground applied to this side of the actuator, the DC motor's actuator. And that motor runs clockwise to extend the actuator out. Alright, now here is when we perform the retract actuator function. We have 12 volts DC up here through the S1 switch is closed. The K1 normally closed contact is closed. The K2 normally contact is open. We flow through the K2 normally open contact into the actuator. Now this side is plus because we have plus applied to this side of the DC motor in that actuator. And we have ground applied to the second side of the actuator through the closed contact here, back to ground. So before, when we were extending out, we were flowing through the DC motor in that actuator in this direction so that this was positive. But now, when we're retracting, we flow through the opposite current flow direction, back to ground. Isn't that amazing? Okay, let's put the next sheet up. I'm getting a little long-winded here, but this is how things get explained. Now, what happens if we push both push button 1 and push button 2 at the same time, so we actuate the K1 and K2 relays at the same time? Here, the normally closed contacts of K1 and K2 open up, so there is no plus 12 volt DC voltage applied to the motor. And at the same time, you can see that K1, K2, K2, K1 have closed. There's no voltage up here. So we don't create a short circuit condition of 12 volts DC to ground through the relays. Here, when K1 and K2 are closed down here, the motor inside that actuator is connected to ground. Nice. Nice. That's a good way to stop that motor. Now, to prevent me from actuating that retract function of the actuator DC motor, I have this switch right here, S1. When I want to prevent me from accidentally pushing that retract button, I open up this switch right here, and you can see here I pushed PB2 and I've closed relay K2. But since this switch is opened, there's no current flow through the DC motor to retract that actuator. Here's the terminal board connections on the front of my box. I've got two plus 12 volt DC connections right here from the 12 volt DC battery. That's positive 12 volt DC connections right there. And on the ground side of the battery, I have two connections right here. The actuator is connected to these two terminals right here. And the relay determines whether this is plus or minus, and this is plus or minus. When this is plus here, and this is minus here, the actuator DC motor is extending the actuator. When this is minus up here and plus down here, the actuator DC motor is retracting that actuator. This 12 volts right here is connected to here, and here, and here. So when I push PB1, push button 1, the 12 volts from the battery goes through the switch into this terminal right here and energizes K1. When I push button 2, this 12 volts up here goes through push button 2 and energizes K2. Now S1 disconnects that 12 volts up here from the retract function. I got a little bit long-winded right there, sorry, but in order to understand what was going on, we had to go through all of these pieces of paper right here. Alright, all. Thank you for stopping by and watch us go through that little invention we got there. Go out there and make you one of those. You have a lot of fun playing with that. Now, remember, this is a 12 volt car battery right here, so you want to use some pretty thick wires in that area right there, and some thick wires going out to the actuator, and you might even want to put some thick wires inside the box if you need to. My actuator was only pulling 2.6 amps, and so I used a standard gauge wire right there. I got some laundry over there in the sink. I got to get out and put on the box fan before I get up and go to work so I can have some clean clothes. So, y'all have a good night, and we'll see you next time.